So we're going to learn some more exponent rules. We learned some in the previous lesson, and now we're going to learn some more. So we're going to learn about the power rule, where if we have a number or a letter raised to a power, like we have something a to the m, and we raise it to a power, this time we're going to multiply. And then the power of a product, if we have a product being raised to a power, that means each one is raised to that power. And the same thing will happen with a quotient. If we have something raised to a power, but it's a fraction, then that means each part is still raised to a power. And of course, b can't be equal to 0 because that would be undefined. So let's go look at these last exponent rules. All right, so example 1. We are looking at our first example. If we have x to the 5th raised to the 7th, then this means we have x to the 5 times 7, which will be x to the 35th. If we have 2 to the 2nd power raised to the 3rd power, then that will be 2 to the 2nd times 3, which will be 2 to the 6th power, which is 64. So we've added and subtracted, now we are multiplying exponents. So if we have 5 to the negative 1 power raised to the 2nd power, we have 5 to the negative 1 times 2, which gets us 5 to the negative 2 power. We can't leave it with a negative exponent, so it has to go down in the denominator to 5 squared, which will be 1 over 25. And don't forget the 1 on the top. If we have y to the negative 3 raised to the negative 4 power, we have y to the negative 3 times negative 4, which will be y to the positive 12. So we don't have to take it to the denominator because the negative signs worked out. All right, let's do some simplification. So if we have 5 x squared raised to the 3rd. Now notice that this has an exponent. This one doesn't already have one. So this will just be 5 to the 3rd, and it'll be multiplied by x to the 2 times 3, because that 2 is only on the x power, or on the x, the variable. So 5 cubed will get us 125, and this will be x to the 2 times 3 is 6. Our next one, we have 2/3 raised to the 3rd power, so that's the same as 2 to the 3rd over 3 to the 3rd. Well, 2 to the 3rd is 8, and 3 to the 3rd power is 27. Our next one, we have 3p to the 4th divided by q to the 5th raised to the 2nd power. So this will get us 3 to the 2nd times p to the 4 times 2 over q to the 5 times 2. So we're distributing that 2, or applying that square to each of our terms. So 3 squared is 9, p to the 4 times 2 would be p to the 8th, and it would be q to the 5 times 2, which is 10. All right, our next one would be 2 to the negative 3 over y raised to the negative 2. So this will get us 2 to the negative 3 times negative 2 over y to the negative 2. On the top, negative 3 times negative 2 becomes 2 to the 6th. Now that y to the negative 2, it can't stay in the denominator, so it's going to come up and become y to the positive 2 as it changes the sign, or crosses the line, it'll change its sign. 2 to the 6th is 64, y squared. If we have x to the negative 5, y squared, z to the negative 1, raised to the 7th power, we now have x to the negative 5 times 7, y to the 2 times 7, z to the negative 1 times 7. This will get us negative 5 times 7. We get x to the negative 35. Y to the 2 times 7 is 14. And z to the negative 1 times 7 is negative 7. We can't leave those with negative exponents, so the y to the 14 will stay on the top because it's positive, but the x to the 35 will move to the denominator as well as the z to the 7. And that would be your final answer. All right, let's go look at some more problems. So this will be example 3. And we're looking again at part A. If we have 2x to the 0, y to the negative 3, all raised to the negative 2. What we need to recognize first is anything to the 0 power is 1. So that doesn't count at all into what's going to happen. So I'm just going to rewrite it as 2y to the negative 3 raised to the negative 2 because that 1 won't change anything. All right, so now we have 2 to the negative 2 power and y to the negative 3 times negative 2. And if you're wondering, well, how come we just raise it to that negative 2? Well, because that's like 2 to the first. 1 times negative 2 gets you that negative 2. All right, we're going to multiply this out a little bit, but we know that 2 to the negative 2 has to go to the denominator. So 2 to the positive 2 once it moves down, and we have y to the negative 3 times negative 2 gets us y to the 6th. 2 squared will get us 4. And that would be our final answer for that one. All right, let's look at part B. If we have 5 to the negative 2, and we have x to the negative 3, and y to the 11 over x squared y to the negative 5. So on this one, we've got to figure out where everybody's going to land. Well, the 5 to the negative 2, I know it has to go in the denominator because I can't raise it to a negative, and it has to have a positive exponent, so 5 squared. On the x's, I have negative 3 up here and positive 2 down here. So I'm going to move the x's to the bottom, to the denominator, because it'll be 2. When that crosses over, it'll be plus 3, so that'll get me positive numbers. And on the y, I have more positive on the top, and so I'm going to move that negative up. It'll become 11 plus 5. So we'll end up with y to the 16 on the top. 5 squared is 25. X to the 2 plus 3 is 5, and that would be our final answer. All right, let's look at example 4. So for example 4, again, we're simplifying. We have 3x squared y over y to the negative 9z, all raised to the negative 2 power. So I'm going to look and see what I can do here first. Now, I have like terms, so I'm going to simplify in here first before I start multiplying by the negative or raising everything to the negative 2 power because it'll simplify our problem a little bit. So I'm going to have 3x squared. My 9, I have negative 9y down here and 1 up there. So I will have y to the 1 plus 9 as I move it up all over z raised to the negative 2. So this will be 3x squared y to the 10 over z to the negative 2. Now that I have it all in one term, it'll be easier when I apply the negative 2 exponent. So now I'm going to have 3 to the negative 2, x to the 2 times negative 2, y to the 10 times negative 2, all over z to the negative 2. for my number, I know it has to come down into the denominator as 3 squared. And then I have x to the negative 4, y to the negative 10. And I know that the z's are going to have to move up because it's all multiplied out. So z squared on the top. Now I know I have to move the x and the y down. So this will be, on our top, we'll have z squared. 3 squared will be 9. The x's will move down. That will be x to the positive 4. Y will move down to y to the 10th. And just those z's are left on top. And that's your final answer.